Alright, this video is about limiting reactants. I'm sorry on the microphone. It seems to be really sensitive to the microphone, so it has a lot of background noise. I can't seem to fix it, so I'm just going to go with it. In class, we're going to be looking at reacting baking soda with vinegar, which is a lab that is in the textbook. And this is an image that I kind of took from my mind, so I'm going to talk through this one, and we'll be doing the actual lab in class. But you can see that each of the flasks in the bottom, they have vinegar in them. And they have different amounts of baking soda. So the top numbers are 2 grams, the 4 grams, the 6, 8, and 10 are the amount of baking soda. When I look at the reaction after it's done, I'm taking a look here, and it looks like not much was happening in that spot, right? It seems like the baking soda, there wasn't quite enough of it, it didn't do a whole lot. This one was just a bust, the balloon broke down. So here we ran out of baking soda, and the reaction stopped going. It seemed to be getting bigger and bigger and bigger and bigger, but then over here, I wonder if they're actually that much bigger. They seem to be about the same size. And if I look a little more closely, I can look at and see that this still has white stuff left over. That must be the baking soda. That's still left over, which says to me that I've got too much vinegar in here. I've got a lot of vinegar, and, take it back. This says to me that I have too little vinegar and a lot of baking soda. So here, I ran out of vinegar, which means the reaction stopped making bubbles. Bubbles is what we're capturing in the balloon. And over here, I had too little baking soda, and so I didn't get a lot of bubbles, and my balloon was really small. From that, I'm looking at what a limiting reactant is. A limiting reactant controls how much you can make. Now, there were 2 reactants in this reaction, and the reaction is right here on the top. NaH2O3 is the baking soda. This stuff is the vinegar. So when I put the 2 together, I'm going to make the gas. That's what I'm collecting in the balloon. The baking soda ran out in this far red balloon one, but the vinegar ran out on this far purple balloon one. So I had different amounts, and my limiting reactant was different depending on which one I had. Let's think of it in this kind of example. If I wanted to make these type of cookies, where you have 1 pretzel, 1 Hershey Kiss, and 1 M&M, and you make these kind of Christmas cookie sort of things, I want to know how many of these can I make. Let's say I give you 45 pretzels and 16 Kisses and 112 M&Ms. Well, how many cookies can you actually make? You're probably going to look at the amount and be like, 112, I can make tons of them based on my M&Ms. I've got only 45 of the pretzels, so I can only make 45 based on those, but I really only have 16 Kisses, so I can literally make 16 of these cookies. 16, you'd say. You can only make 16 cookies. Yeah, you're totally right. Think about how you did that problem. You looked at each of the numbers and said to yourself, how many can I make from each of these pieces? That was helping you determine what the limiting reactant is. In this case, your Kisses was the limiting reactant. It controlled how many cookies you could make. Now, we can't be as simple as that sometimes. Let's say you're making s'mores. You would still ask yourself, out of these pieces I have, how many s'mores can I make? Now, each s'more is a little bit different. I'm saying these s'mores, you need to use 1 marshmallow, 3 rectangles of chocolate, and 2 squares of graham crackers to make a s'more. Which means, if I look at the marshmallows, I can make 6 s'mores based on the fact that I have 6 marshmallows. From the graham crackers, I can make a total of, well, each sandwich needs 2, so I can make a total of 5 s'more sandwiches from my 10 crackers. Now I have the most of the chocolate. I've got 12 rectangles of chocolate, but each sandwich needs 3 pieces. So 12 divided by 3 gets me 4. I can only make 4 s'mores from the chocolates, which means I can only make a total of 4 s'mores because I have run out of chocolates. This one's my limiting reactant. So when you decide a limiting reactant, look at the steps you're doing. You're asking yourself, how much can I make from each of my pieces? And then we'll see which one runs out first, chocolates in this case, and that tells us how much we can actually make. We're going to do math with this in the exact same steps. We're going to look at how much we make with each of them, and then take the smallest number, 4 in this case. Alright, so bring it back to the mole map here. Let's take a look at this problem. I have 2.7 moles of this. I have 6.3 moles of this, according to the problem. And it says to identify the limiting reactant, and how many moles of water can I make? Okay, so just like the s'more question, I'm going to ask myself, how many sandwiches can I make from this piece? How many sandwiches can I make from this piece? How many sandwiches can I make from the squares? Same thing here. So how many moles of water can I make? That's my same question every time. It's just that now I have 2 different numbers, so I have to ask myself, well, which one am I going to run out of? So how many moles of water can I make from 2.7 moles of C2H4? And how many moles of water can I make from 6.3 moles of oxygen? Same steps as before. Now I just have to do math instead of deciding s'more cookies. So now that I got my problem set up, I'm just going to start doing math. I'll put moles of C2H4 on the bottom. That way they cancel. I'll go up to my mole map here. I can see that I'm going from moles to moles. So it's really going to take me one step, and I'll use the balanced equation. Alright, I'm going from moles of C2H4, and I want to go 2 moles of H2O. I'll look at my balanced equation there. There's a 2 by the water, so I'll put a 2 on top. And when I look at my C2H4, there's a secret 1 there, so I'll put a 1 on the bottom. So now I'm doing 2.7 times 2 to get how many moles of water I can make, and that would equal out 5.4 moles of water. So from this much of C2H4, I can make 5.4 waters. Sounds good. I don't know what you're doing, screen. There you go. Going back to the bottom. Now I'm looking at oxygen. So I'm going to take out moles of oxygen, put them on bottom, that way they cancel. And I want to go again to how many I can make. So I'm going to go to moles of water on top. Again on the mole map, I'm going from moles to moles, so it's just only one step. I got to use my balance equation. This is a 2 in front of the water, so 2's got to go there. My moles of oxygen, I looked at the beginning, I've got a 3 there, so I've got to put a 3 on the bottom. So now my brain's thinking 6.3 times 2 divided by 3. And my calculator says 4.2. Alright, now I've got all my math, now I've got to do the thinking. I can make 5.4 water, or I can make 4.2 water. You want to take the lower number. Just like with the s'mores, I can only make so much water because after I make 4.2 moles of water, I run out of oxygen. This one's my limiting reactant. It controls that I can only make 4.2 moles of water. Then my oxygen ran out. The C2H4 would be called the excess reactant. I've got more than enough of that. I could make 5.4 moles of water with that. Of course I can't though because I'd run out of oxygen. In the lab, the tricky part is we can't actually measure using the mole. Like I can't put on a balance and say, oh, this scoop of solid is worth 5.6 moles. It doesn't work that way. We've got to go to grams. So I'm just doing some shorter problems, and that's what your textbook is, actually, but we can't do that in the lab. We've got to go to grams when we're dealing with actual lab numbers. So keep that in mind when you're doing the lab for this. Okay, let's take a look at this problem. Identify the limiting reactant if 1.2 moles, I like to put it up in the numbers, reacts with 5 grams, and determine how many moles of hydrogen can be produced. See, when I put the numbers right in the problem, it makes it so much easier. I can see what I want to find. My question mark's right there. So I'll go question mark, moles of hydrogen, equals, and then I've got 2 numbers, which means I'm going to have to do this problem 2 times. I've got to figure out which one do I run out of first. That would be my limiting reactant, and then that'll tell me how much I make. But I can't look at the numbers. I can't be like, 5, 1.2, 1.2 will run out first. You can't ever do it that way. You've got to do the math. First of all, one's in grams and one's in moles. Second of all, this has a 2-to-1 ratio, so that's going to affect things too. So always do the math. Don't just pick the lower number. Alright, I'll start with 1.2 moles of HCl on the top of this one. And with this one, I'll do 5 grams of magnesium. Got to test out both of them. So I'll do the moles of HCl first. I've got 1.2 moles of HCl, so I'll put moles of HCl on the bottom. That way they'll cancel. I'm going to go straight to moles of hydrogen. That's just like the last problem. It's just a mole-to-mole problem. So I've got to use my balanced equation. HCl's got a 2 right here. Put a 2 on the bottom. H2's got a 1, so I've got to put a 1 on top by H2. And now I just got to push buttons on my calculator. I'll do 1.2 divided by 2, and I got 0.6 moles of H2. I got to go to the bottom problem now. I've got grams of magnesium on this one, so I'm going to put grams of magnesium on the bottom so they cancel. Now if I look back at the mole map, I'm currently in grams, and I've got to go to moles, so I've got to go 1, 2 steps here. So grams of magnesium on the bottom, I got to go to moles of magnesium on top. This is where I'm using the periodic table. I know that 1 mole of magnesium, on the periodic table, magnesium is 24.305, so I'm going to put that on the bottom to go with grams. Now I can do my last step, moles of magnesium on the bottom, that way I get rid of them, and I got to go to moles of H2 on top. For those numbers, I got to use the balanced equation. This moles of H2 goes with this 1 in front of it. The moles of magnesium goes with its imaginary 1 in front of it. And then I can push buttons in my calculator. 5 divided by that 24 got me 0.21. Alright, so I got two numbers. Now I gotta think about it. What am I going to do with this? I can make 0.6 moles of H2, or I can make 0.21 moles of H2. You want to pick the smaller number. That's this one down here. This is how much I make. I can only make 0.21 moles of H2, because after I make that, I've run out of my magnesium. It's the limiting reactant. My magnesium will run out after I make 0.21 moles of hydrogen, which means I can only make 0.21 moles of hydrogen. Alright, I hope that helps.